What's going on, everybody? Today we are going over programming paradigms in C++. Now, if you don't know what programming paradigm means, it basically means a way of thinking about and structuring your code. It's the approach or the style that you use to solve problems with programming. Now, it is important to be able to distinguish the differences between these paradigms, especially if you're unfamiliar with how they look like in C++. Now, of course, there are many programming paradigms, but I'll be going over the major four, which is object-oriented programming, functional, procedural, and event-driven. We're going to be starting with object-oriented programming first, which is actually the most common and what beginners first learn. Put it like this, if you're unfamiliar with this paradigm, it's about modeling real-world objects and representing them virtually. You create classes, which you can think about a class as a blueprint, which basically consists of instructions and data for how to create new objects and how to use that object. Now, I won't go completely in depth with object-oriented programming on a conceptual level or even in this C++ tutorial, because it's just more about a quick overview about the paradigm and how it looks in C++. But if you want a full tutorial about object-oriented programming or any other paradigms you're about to hear in the rest of this video, let me know in the comments. But with that out the way, let's begin with a simple example, and then I'll move on to a real-world example, and that'll pretty much be the pattern with all the rest of the paradigms. Okay, so here we are with our example for object-oriented programming, which is just a quick little pet simulator. So really quickly, OP, which is short for object-oriented programming, is about modeling real-world objects. Each object has members called data, variables, and behavior, methods, or functions. So here we create a virtual pet class, and that is right here, the class that we are defining as pet. So like I said earlier, you can think about classes as a blueprint. So this right here is a blueprint for the pet. So you do have this member here, which is going to represent the name of your pet. And then you have this constructor here, which actually constructs the object. So you could think of it as taking this blueprint and creating a new pet. Down below here, you have two methods or functions. The first one is called feed. The second one is called play. It just pretty much prints the pet's name, and that's what you see here. And you say is eating for the feed one and is playing for the play one. This entire thing makes up our class. So the whole point is now we have a blueprint for our pet class in which we can construct as many times or create as many times as you want and assign them to some variable. That is the main point to this paradigm, and that's why it is called object-oriented programming, because it relates to objects. Because when you take that class and you construct it, you create an object. The class itself is not an object, it's just a blueprint allowing you to create objects of that class. It's just the instructions and all the data that you need to create those objects. And then once you have that, you can create as many objects as you want. So back into our code, at our entry point here, you can see the first thing that we do is take that pet class and we declare a variable called dog. We give it a name. So the dog's name is Max. And what we essentially did was take this blueprint here and we constructed a new object. So now we can use this variable, which represents that object, to call the functions or methods. So we call the feed, which is right here, and we call the play, which is right here. Now, if I want to, like I said, we can create as many as we want. So we can say dog 2, we can say dog 3. We can create as many as we want. Now, the only reason why it's right squiggly lines is because this is the only constructor that we have here. I'm not going to go deep into that, but it requires a pet name. So you do have to give it a pet name. So there you go. You have your first dog here and second and third. Create as many objects as you want and it will work. Okay, so yeah, pretty simple with this programming paradigm. You can see why that this is the most common one that any programmer, beginner, and even seasoned, they use this programming paradigm the most, is because it relates to our real world. Now, before we move on, I want to show you a more real world example of where you will see this, because that pet simulator, that's something maybe you'll see in a game, but this real world example is something that you'll see more in your everyday life. Okay, so here we go for our second example of object-oriented programming, which is a banking account system. So just like before, how I went over classes, you have this class here, which we call bank account. And for a private member here, we have our balance, which will hold the balance for this bank account. We have our constructor, which will take initial balance. So think of it as opening up a bank account and depositing some initial balance. So we just assign that initial balance to our balance member here. And then we have 3 methods. We have a deposit method to deposit money, of course, withdrawal to withdraw money, and then this print balance. That way we know what our current balance is. It's just us printing stuff out and then doing some quick math to adjust the balance. Going down below to our entry point, you see that we constructed an account and we initialized it to 100, which meaning that that's our initial balance. So we have $100. And after that, then we call the deposit to deposit $50, and then we decide to withdraw. So we withdrew $30. And then lastly, we just have a print balance to get the current balance at this particular state. And like I did before, we can create as many bank accounts as we want. I can create another one down below and say bank 2, 3, and 4, whatever, or other people who have their own bank accounts. Okay, so yeah, pretty simple. The most common paradigm that you're gonna come across is OOP, object-oriented programming. Now, the next 2 paradigms are functional and procedural. I'll actually go over procedural first and then go over functional. You might have heard of these, you might have not. These 2 people sometimes get confused because they sound similar, but there is major difference with them. I'll go over it when I go over the second one. Let's just go over procedural first and then move on from there. Okay, so here we are in our example for the paradigm procedural. Like before, I will go over this example and then I'll go over a real world example. But just to give you a little bit of background about procedural programming. So it is a program paradigm, of course, that follows a sequence of steps called procedures, aka functions, to perform a task. It focuses on instructions and changing the state of variables, variable or variables. Think of it like following a recipe, step by step. Now, in this example, which is called making a sandwich, we build a sandwich by calling a series of functions or procedures that modify a shared global variable called sandwich, which you see right here. And then at each step, it takes this shared global variable and changes the state. Now, when I say changes the state, I mean at some point it could be like this, and then some other point it could be like this. I basically just mean updating the value. Now, I hope that made sense, but just to reiterate here, you will have external variables, right? And you will be changing the state of those external variables through these procedures, which procedures are just functions. That right there is the main rule to this style, to this programming paradigm. Okay, so down below here, we have these procedures here. We have the add bread, we have the add peanut butter, we have the add jelly, and then add plate. And then we have this procedure here, which pretty much collects all these other procedures and makes a sandwich in a particular order. As I set up here, a step-by-step recipe, that's what it does. It calls these functions step by step. And these functions, they don't have a local variable called sandwich. It takes that global variable and updates the state of it. So if you look at make sandwich, we first add the bread, right? That's what we're calling. So when we call that function, it goes inside of here, it takes sandwich, which at this point, sandwich doesn't have anything inside of it, and it just concatenates it. That's what the plus equal is, right? We're just taking this string and adding it to this string, which is just currently empty. And then the next thing we do right here is add peanut butter. So we call this function taking that global variable again, and we're just adding this to it. And now this right here, this escape, it's just basically to line break. So that way we just go to the next line. So it will look like a sandwich. Anyways, we keep going. We add jelly, we add the last bread, and then we add the plate. Now in our entry point down here, we just call that make sandwich, which is going to call this one, which will call all of these in order step by step, which all have access to this global variable, which will just change the state of it at each step, each procedure. So if I actually run this, which I will for you, and by the way, this whole repository will be made available. The link will be in the description, so you go ahead and click on it. And I made it very easy to run it. All you have to do is go to your run debug. And in this case, click this drop down. We will go to, this is procedural, so the fun example. Click on that, and then just hit the run button. If it goes to the debug console, just make sure to switch back over to the terminal. And we see this here, your sandwich, and this is the sandwich. This is the plate down below, or just my attempt at a sandwich. The plate down below, the bread, the jelly or the peanut butter, not sure. One of the others the jelly, one's the peanut butter, and then the top bread. That sandwich does not look good. Whatever, I tried. So yeah, that's it. That's the whole point of procedural programming. It's step by step, and you update some global variable. Now let's look at a real world example. Okay, so this is something more common to you, processing an order. So what this code does is that it calculates the final total of an online order by updating shared variables step by step. It simulates a simplified backend process used in e-commerce. So right here you have a couple of variables that is in the global space. You have the subtotal, the tax amount, the discount amount, and then the final total, which we will be changing the state of each one in the following steps. So right here you have the add item, which allows us to add the price of each item, and we can add as many items as we want, and that price will be added to the subtotal, which remember, subtotal is a global variable, so we are just changing the state of the subtotal every time that this function is called. Next here we have the apply tax, which we just pass in some tax rate, and then once again just some simple mathematics, and that will update the tax amount, which also is an external shared variable, and then the total, also external variable. Lastly, we have this apply discount, which we just apply some discount rate, taking the subtotal, multiplying by the discount rate to get the discount amount, and then subtract it out of the total. Hence, once again, you are changing the state of these global variables as seen up here. Now down here, you just have the calculate total, and then you have the print receipt. This does change the state as well, obviously. And then the print receipt is just printing. So in our main entry point, we have two items that we're adding, one that costs $29.99, and then another one that costs $15.49. Now I added these little helper comments here to just let you know at what stage what's happening. So at this stage, we just added $29.99 to the subtotal, and that's what that is. Now at this stage here, when we added both items, the subtotal at this point should be $45.48. Now when we apply the tax by calling that procedure, what's going to happen to that subtotal is that it's going to give us a tax amount of $3.18. Next, when we apply a discount, which is a 10% discount, we apply that using the subtotal once again, and that is $4.54 or 55 cents if you round up. And then finally we calculate the total using everything that we have, which should come out to $44.11, and then we just display the results. So once again, we're going to run this so that way you can see exactly this right here. Okay, there you have it. You have the subtotal, which is $45.48, which is what I believe I said, the tax, which is $3.18, and the discount amount, which is that much, which you get to take off, and then the final total with the customer, which must pay. So yeah, it's pretty simple. Just remember, procedural is step-by-step procedures that change the state of a global variable or variables. Now I keep stressing that because the next paradigm, which is functional, seems like it's similar, but there is a big difference, and I'm going to go over that next. Okay, so here we are in our functional paradigm programming example. Remember, this isn't the real world example. This is just the first example. And with this example, we will be making a smoothie. But first, functional programming focuses on pure functions. These functions always give the same output for the same input and avoid changing external state. So at this point, I'm pretty sure you could start to put together the main difference here. We are avoiding changing any external states. And the main point is to have the same output for the same input. Okay, so in this example, we blend ingredients and return the smoothie as a string. Now I added this extra piece here so that way we could really go over the difference between procedural and functional. So functional works with pure functions and constant values. So the state never changes. The same inputs always give the same outputs. So parameters must be treated as immutable, even though C++ doesn't enforce this because it doesn't. In functional programming, you should either declare them as constant or make sure that you don't modify them inside the function. Procedural works by calling functions that change external variables, as we saw in the last example, updating the program state step by step. Here, meaning procedural, parameters and global variables are meant to be mutated. That's the whole point. You take something, you modify it, and you keep going. Remember, that's the step-by-step procedures that you take in some external variable, you're changing its state or modifying it, and then you keep going. You go to the next procedure. And that's what we saw before. We had a sandwich, which was a global variable, and then we had the add bread function amongst other procedures that we took that sandwich global variable and we changed its state. Okay, so with that out of the way, let's just go into the code. So down here, we have a function called blend smoothie. So what it does is it accepts a constant vector of string, and it's going to be a reference to this vector, which is going to be our ingredients. It's going to return a string, which will just be our blended smoothie. So inside the function, we have a local variable called smoothie, which is going to be what we're going to return. And we just start by saying blended, and we're going to actually add the ingredients. So what we do is we take those ingredients, which is in our collection of vector, which is a collection of string, just to clarify. So we take that, we loop through it, and all we're doing is adding it to the smoothie. And we just add a space, that way, we don't have everything close together. Once we're done with this whole entire loop, we just return the smoothie, and that is it. So you can see right there that we have some input is going to give us the same output. It is not taking some global variable and changing its state, which could be different. In this case, no. Every time you have the same input, it's going to always give you the same output. I hope that makes sense. So looking at our entry point down here, we do have my ingredients, which is a vector of strings, and we have banana, strawberry, and almond milk. So we take this collection and we pass it into the blend smoothie, and then we just print out the result. So to point out the parameter and why we use constant is because we don't want any accidental modifications to this vector, because we aren't changing the state. We just want to take it and in this case use it to create a smoothie and then return that. We don't want to modify this. I really hope that that made sense and I explained it good enough. Let me know in the comments if anything is confusing and I will clarify it up for you. But moving on to the real world example of functional. Okay, so here we have something very similar to what we just did with procedural, and that's why I said that they are very similar, but you're gonna notice really quickly how this one just does it differently. And the big difference here is that these functions, they're not procedures, they are functions. They aren't procedures that are modifying some external state. So if you compare them side by side, you can see the big difference here. So calculate tax, so when you look at the subtotal tax rate, you can see that we passed in information, right? And it calculated it and then it returned, rather than here, which is our procedural. So this total and the tax amount, both of these variables are external and we are just changing the state of them. At the end of the day, this function here, which is called a procedure, it actually is modifying the state of something externally. In comparisons over here, our functional paradigm, we see this function here does not modify any external states. It just takes some values that were passed in, does some computation, and then returns the result. And you see that with every single one of these. So with this real world example, it is pretty much the same thing. It's a billing calculation. And I say here, instead of modifying shared state, this version uses pure functions to compute subtotal, tax, discount, and the final total in a predictable way. The other way isn't predictable because we are taking state, modifying it, and now those states are forever modified. In this case, every time we pass in, and let's say get subtotal, every time we pass in $1.99 and $2.99, we're going to always get the same result back. So I won't really continue going over it because it is pretty much the same thing. Once again, if something doesn't make sense to you, please let me know in the comments and I'll be more than happy to help you out. Now, before we go into the last paradigm, which will be event driven, this is just a friendly reminder to hit that like button, hit subscribe if you haven't already. If you're watching this up to this point, then that means a lot to me because you stood on this long, and that's good for my retention. So thank you for that. Really, thank you for your support. It motivates me to keep making videos like this. Okay, enough of my plug. Let's get back to it. Okay, so here we are in the last paradigm, the event-driven programming. Now, with this example here, this is a virtual button that we are creating. It's very simple. So, event-driven programming responds to user or system actions, which are called events. Here, we simulate pressing buttons that trigger specific responses. Now, this example is super boring because it's not a real button. It's like a simulation of clicking a button. It's something that you could definitely see in like a video game or something like that. Yeah, you'll see in a second. It's super boring. The real world example is much funner. But let me just go over this real quick. Anyway, so here we are. We have our onClick function, which will handle the event. So down here, we have a string called user action, which will just hold what the user inputs, because we are using cin to capture the input. And we just let the user know that they can press a button. They could either press start or quit, which just means that you actually have to type in start or quit for it to work. Super boring, I know. Anyways, once we get that input, which by the way is blocking, I'm not going to go over that, but that's why it's just a quick example. Anyways, we're gonna call the onClick function, which will handle that input. That's the whole point of event driven. Once this event happens, then we handle it in some function. So we take that input, pass it into the onClick, which will just be the button name. So we're gonna check that button name. If start was inputted because the user did input start, then we're gonna say game started. If they input quit, then game exited. And if they input anything else besides exactly start or quit, then it's just gonna say unknown button pressed. Yeah, I don't think I should run this. I mean, if you want to run it, go ahead, but it's pretty straightforward. Let's just go over the real world event. Okay, so here we are. Real world example, that is a smart home sensor system. Now, when I say real world example, obviously it doesn't have, like, you can't use this. Like, it's not gonna really be a smart home sensor system. I just feel like I have to say that just in case if somebody has that assumption. It's just something that replicates or that simulates something that's more realistic rather than that stupid button clicking one that I just showed you. Anyways, what this example does is that it simulates how an event loop might dispatch events to handlers in a real world embedded or GUI system. Each sensor triggers an event and the system responds by calling the appropriate handler. Now, I'm gonna brush through this kind of quickly. I'm not gonna go too in depth because if you are a beginner, this may be a little bit too much for you because I do use like functional map and it's a couple different things that I'm using here that you may not have seen. So I'm not gonna go too crazy, but the whole point to this paradigm is that what we are doing, let me just go down to the main function. So what we are doing is we have some class, which you already know what classes are. So we create this class, which is the event dispatcher. So it's going to dispatch whenever the event happens. So the whole point to this event dispatcher is that it will allow you to register events, which you can do here with this function, and then to emit whenever these events happen, to basically handle it. And these functions will be assigned to whatever you registered into our listeners map. So we register some event handlers, right? So if the temperature is too high, we're going to call this function. If the door opened, we're going to call this function. And if the motion, if a motion is detected, then we're going to call this function. So you can think of it as like literally sensors that we are assigning some function to. So whenever this is triggered, while temperature is too high, it knows to call this function. And that's why it's yellow, because it is referring to this function here. And this one is referring to this function here. This one is referring to this function here, which is just going to print temperature too high, turn on fan, log doors open, recorded at whatever time, and then alert, motion detected in living room. So we registered 3 event handlers based on these triggers here. Now here we just print out temperatures high, and then we just call this to emit. So basically we're triggering it. We're saying, hey, you know, it's too high, so just call that to emit that, which it knows to call this function. And then we do the same thing with the motion detected, and we do the same thing with the door open. And then we do this with the unknown function, which let me see if I remember. how it's handled. It's just going to call this right here. It's going to say no handler for this event because we didn't register anything that's called the unknown event. We only register these things here. Okay, so that about covers it. If you have any questions, please let me know in the comments. If you want me to go more in depth with any of these paradigms, also let me know in the comments. And if you have any suggestions about future videos that about other topics that you want me to cover within C++, also let me know in the comments. But if you found this video insightful, please consider hitting that thumbs up. Also consider hitting that subscribe button because it just motivates me to keep going. And with that said, I am Ghost, but just remember, think like an engineer, code like a ghost, and I'll see you in the next video. You like my little corny catchphrase? Get used to it. Seriously, I'll see you in the next video.